Okay, so I know that we talked about moles last time, and we talked about converting moles and how many particles were in a mole, whether those particles were atoms, whether they were molecules, whether they were formula units, electrons, ions, whatever they were. We talked about how many particles were in a mole, and that number was 6.02 times 10 to the 23rd, which was Avogadro's number. Today we're going to talk about how much mass is in a mole and how to figure out that quantity for different elements and different compounds. The masses of each mole can differ between or among, depending on what elements are in the mole. You'll see here in your notes that the molar mass of any element is numerically equal to its atomic mass and has the units grams per mole instead of atomic mass units, or AMU. You will need your periodic table. So if you don't have your periodic table, you need to pull out your periodic table for this because you will need it. All right, so let's look at this slide. So it gives you an element and it tells you that its mass is 1.008 AMU. If that is its atomic mass, then its molar mass is 1.0008 grams per mole. That's simple. Potassium's atomic mass is 39.098, so its molar mass is 39.098 grams per mole. So we're getting a conversion factor from moles to mass for each element when we're looking at the periodic table. Tungsten is 183.84 atomic mass units. One atom of it, so 1 mole of it is 183.84 grams per mole. Bromine, 79.904 atomic mass units in an atom of bromine. There's 79.904 grams in 1 mole of bromine. Okay? Knowing that, now we can go to the next step. All right? So this chart was in your notes. I'm not sure if you copied it or not. If you did not, and if you're watching this video, pause the video so you can copy this chart and fill it in. And do this on a separate sheet of paper because this is going to be part of your assignment that you turn in. So do this on a separate sheet of paper, and I'll collect this assignment for my in-class students. I'll take it when we get back to class. For my virtual students, you'll post it in the discussion question on Schoology. All right, so you should have this copied by now, whether you had to pause or you already had it copied from before. We want to figure out what is the molar mass of these compounds. You saw here how to find the molar mass of separate elements, but what about when we get them in a compound? So let's start with hydrogen peroxide, H2O2. All right, so if we look at hydrogen peroxide, first you got to look at your elements, and then you got to see how many you have of each element. So I'm going to do all my work down here for each one. So I have hydrogen, and I have 2 of them. And then I'm going to look at my periodic table, and I'm going to see what my atomic mass is. And on the periodic table, my atomic mass of hydrogen is 1.008. So I know I have 2 hydrogen atoms that have this atomic mass. And so when I multiply those together, I'm going to get 2.016 total. Now I need to do my oxygen. If I look at my formula, how many oxygen do I have? I have 2. So oxygen is going to be 2. My atomic mass for oxygen is 15.999. So the total there is going to be 31.998. And so since both of those are in my formula, how do I get the molar mass? Well, I have to add these 2 numbers. And when I add those 2 numbers, I get a total of 34.014. And so I know that in 1 molecule of hydrogen peroxide, I have this, but my molar mass is 34.014 grams per mole is my molar mass. So in 1 mole of hydrogen peroxide, I've got 34 grams of peroxide to make 1 mole. If you have any questions, just keep watching, and you can definitely message me if you have any. All right, let's go to the next one. Let's go to acetic acid, vinegar. I've got CH3COOH. So I'm going to write down my elements. I've got carbon, I've got hydrogen, and I've got oxygen. All right, carbon, how many do I have in this formula? 1, 2. So I've got 2 carbon. My atomic mass for carbon is 12.011. And so my total mass of carbon in 1 molecule of acetic acid is going to be 24.022. All right. And if I look at hydrogen, I've got 3 here and 1 here. So I've got 4 total. So 4 times 1.008. And that's going to give me 4.032 total of hydrogen. And then oxygen, I've got 2. 1, 2. 2 times 15.999. That's going to give me 31.998. And so I've got these 3 numbers and what I have of each element, but I need the total. I need the whole molecule together. So I'm going to add these numbers. I've already done all that for time's sake, so it wouldn't slow me down in the video. But when you add all these up, you're going to get now I can't read my writing. I'm going to get 60.052. 60.052. So if I go up here to acetic acid, now that I've added all these up, my total mass in 1 mole of acetic acid, not 1 mole of carbon, not 1 mole of hydrogen, not 1 mole of oxygen, 1 mole of acetic acid is going to be 60.052 grams per mole. Okay? All right, so the next 3 you're going to need to come back and do on your own, okay? Do remember your parentheses here. Phosphorus, you'd have 2. Oxygen, you'd have 8 here due to those parentheses. But the next 3, I'm going to let you go and finish those on your own. But I'm going to move on in the lecture. All right, so if I'm looking here, I'm going to convert either from mass to moles or moles to mass. Remember, we're going to do mass in grams on this. But I really want to focus, when I start, I want to focus on what I am looking for, because I need to put that on top. I need to put what I'm looking for on top to make sure that I end up with the answer in the units that I need it to be in. Okay, so the best way to do this is just to jump in and look at different examples. So you need to get your textbook and turn to page 328, numbers 15 and 16. We're going to do a couple of examples. I'm going to do one example from 15 and one from 16. Leave yourself some room for what we don't do, because you're going to have to come back and fill in the blanks. Okay? So let's look at page 328, number 15. Page 328, number 15. And we're going to look at A. 15A. All right? And the reason we're able to do this now is we know how many grams would be in 1 mole of any substance, and we can learn that by looking at its atomic mass in the periodic table. So if I'm looking at 15A on page 328, (15A) says determine the mass in grams of each of the following. So I'm determining mass. Okay, I am determining mass, and so my answer in the unit should be in grams, mass in grams. 15A says 3.57 moles of aluminum. So I want to know how many grams are in that many moles of aluminum. Well, I have to look for a conversion factor, which is something I know. What's an equality that I know? Well, I know that I need grams on top because it says determine the mass. And so, what do I know about grams of aluminum? Well, I can look at my periodic table and I can tell you that there are 26.982 grams of aluminum, because that's its atomic mass. So there's that many grams of aluminum in 1 mole of aluminum. Okay, notice now, I wanted to find grams of aluminum because it says determine the mass in the book. So I made sure to put grams of aluminum on top. So I need to be left with that unit. How do I cancel out then moles of aluminum? Well, look at what it gives you. It gives you 3.57 moles of aluminum. So 3.57 moles of aluminum. Look at there. Now I can cancel out moles of aluminum and I'm left here with that unit that I need. And so when I multiply that out, I'm going to get there are 96.326 grams of aluminum in 3.75 moles of aluminum. Sorry, 3.57 moles of aluminum. So this is my answer. Okay? Focus on what you're finding, put that on top, and then start trying to cancel out units. Okay? Alright, so leave a little space for 15B. Leave a little space for 16A. And we're going to skip to 16B. Okay, we're going to skip to 16B. Alright, so go to the next slide. So we're on page 328 still, and we're at number 16B. 16B is telling us, convert each given quantity in scientific notation to mass in grams expressed in scientific notation. At this point, I just want you to be able to express it. And if it ends up in scientific notation, that's fine. If it doesn't, it's fine. But I just want you to be able to get the process right at this point. So it says to mass in grams. So we still need grams on top. All right, so let's do 16B. And it gives us 3.45 times 10 to the second moles of, I'm sorry, that's A. Let's do B. 2.45 times 10 to the negative second moles of zinc. All right, well, what do I know about zinc? Off the top of my head, I probably don't know anything, but you know what? What can I find out about zinc? I can look at the periodic table, and I can find its atomic mass. And once I do that, I know that there's 65.39 grams of zinc in 1 mole of zinc. Okay, so I've got the unit I'm looking for. It's wanting me to determine the mass. So I've got the unit I'm looking for on top, and I've got what it's equal to on bottom. But this is the unit I want. So what have I got to do with this unit? Somehow I've got to cancel it out. All right, so look at what they give you in the problem. They give you moles of zinc. 2 times 2.45 times 10 to the negative second moles of zinc. And that cancels this out, that cancels this out. So now I can work the problem. Now, like I said before in the last class session, if you want to put that over 1 because it bothers you, then you go right ahead. It won't hurt anything. All right, so now I'm going to do my calculations, and I'm going to do 65.39 times 2.45. And I'm going to get 160.21 times 10 to the negative second. But I can't leave something in scientific notation like that because this number, this digit is not a 1 through 9 digit. It's not a single digit, so I can't leave it like that. So what I'm probably going to do is just go ahead and move the decimal where it's supposed to be. It's supposed to be to the negative 2, so 1.60 grams of zinc is what I'm left with. 1.60 grams of zinc. And if you would, please go ahead and get in the habit of putting that rectangle around your answers for me. Okay? Now, let's move on to 17A. All right, let's move on to 17A. Let me check, make sure there's nothing in the notes that I really want to show you here. No, we're fixing to just jump right in, so I think we're good. All right, so let's move on. The next set of examples, that was 328. The next set of examples is going to be on page 329, number 17 and 18. 329, number 17 and 18. So let's go back to the notebook here. So page 329. I'm going to do 17A for you. We're looking at 17A. Now we're going the other way. Instead of going from moles to mass and finding the mass, now 17, if you look at the direction, says to determine the number of moles. We're finding moles, so we need to make sure that we put moles on top. All right, so the first thing we're working with in 17A is Ag, or silver. So we want to know something about moles of silver. Do we know anything about it off the top of our head? No, but we have our tool, the periodic table, in our hands to be able to figure it out. So we know that in 1 mole of silver, if we look at the periodic table, there's 107.868 grams of silver. That's what we need our answer in, because it says determine the number of moles. This is our equality here, or our conversion factor, grams of silver. So we need to cancel out somehow this grams of silver. But if you look at what it gives you 25.5 grams of silver. Now we have canceled that out. Okay? So now, just for simplicity's sake, again, if you want to put it over 1, you do that. If that helps you, then by all means you go ahead and do that. But I'm just going to break it down into what we have and get rid of some of this extra. I've got 25.5 over 107.868. And when I work that out, I'm going to get 0.2364 moles, because that's the unit I have left that I have not canceled out, moles of silver. Okay? So that is my answer. So leave you some space for 17B. Leave you some space for 18A. And I'm going to go ahead and do 18B with you on page 329. So I'm going to do page 329, 18B. All right, so it wants me to convert each mass to moles. It says express the answer in scientific notation. Again, if you want to express in scientific notation, that is fine. Right now, I just want you to do the process. So as long as the answer is correct, whether it's in scientific notation or not, at this point, I just want you to be able to do the process, okay? All right, so I've got 1.00 kilograms of iron. What do we see wrong with that to start with? It's in kilograms. Well, what do we need to work with? We need to work with grams, okay? So we need to go ahead and convert 1.00 kilograms of Fe to grams. All right? If we convert that and do our King Henry died by drinking chocolate milk, that would move our decimal over 3 spaces. So 1 kilogram is going to be equal to 1,000 grams. All right, so now we can work. We've got something we can work with. It's in the unit we need. And remember what we're finding. Always ask yourself, what am I finding? You're finding moles. So what do I need on top? I need moles on top. Moles of Fe. What do I know about that? Let me look at that periodic table. I know that in 1 mole of Fe, there is 55.84 0.47 grams of Fe, or iron. All right, I need that mole of Fe. That means I need grams of Fe canceled out. How do I cancel it out? I look at what they gave me. They gave me 1,000 grams of Fe. So I can cancel these out. And when I do top times top, I've got 1,000. Bottom times bottom, got 55.847. So now I just divide that out, and I've got 18.002 moles of Fe. Now, if I wanted to turn that into scientific notation, I would just rewrite it with the decimal here, times 10 to the first, because it only take one move to get that decimal where it needed to be, moles of Fe. Okay? All right, so the next set of problems, if we look, we're adding another step. So we did moles to atoms yesterday, or representative particles. It could have been atoms, it could have been molecules, it could have been formula units. And today we're doing mass to moles and vice versa. So we're going to add a step in there where you can do all three together, okay? Again, it's just about remembering what to put on top, okay? So we're looking at page 331, numbers 19 through 21, okay? 331, 19 through 21. I'm going to do a couple of these with you, okay? So let's look back to the notebook. Let's look at page 331. And let's look at 19A. Let's look at 19A. 19A tells us on 331, or it asks us, how many atoms are in each of the following samples? So what are we looking for? We're looking for atoms. Atoms is a particle. How many particles are in 1 mole? If you think back to last class period, 6.02 times 10 to the 23rd. We're going to use that Avogadro's number over and over again. So, how many atoms? So I want atoms on top. All right? Atoms. And if I look at number 19, I'm dealing with the element lithium. So I want to know how many atoms of lithium are in a certain conversion factor we have. So I got to think about it. What do I know? I know that there's 6.02 times 10 to the 23rd atoms of lithium in 1 mole of lithium. Okay? But it gives me grams of lithium. How am I supposed to cancel that out when all I have is atoms and moles? Well, think about a conversion factor that will link you to grams. Okay? I need my answer to be in atoms. I have moles here, so I need to cancel out the moles, which means I need to put moles on top here. Well, what do I know about moles of lithium? I know that in 1 mole of lithium, there is 6.941 grams of lithium. How do I know that? I looked at the periodic table. I looked at the atomic mass in the periodic table. All right, so I've canceled out the moles of lithium here. How do I cancel out grams of lithium? I just look at what it gives me in the book. 55.2 grams of lithium. Now I can cancel out grams of lithium, and I'm left with what I want. Okay, so if I multiply this out, top times top and bottom times bottom, I'm going to get 342.24 times 10 to the 23rd over 6.941. All right, so what I can do now is I can take my calculator and calculate out 342 342.24 divided by 6.941, and that gives me 49.31 times 10 to the 23rd, because there's no exponent down here, so we're just going to leave that where it is. But can I leave this answer like it is? No, because when I have it in scientific notation, I need that decimal to be after the first digit. All right, so I'm going to make that equal 4.931 times 10, and I moved it one away from where it's supposed to be, because it's supposed to be 23 spots down this way. I moved it one further away from where it's supposed to be, so I'm going to give it an exponent of 24. Okay, and that is atoms of lithium. That is my answer. All right, and let's do 20A. One more. Let's do 20A. All right, so this is on page 331. This is number 20A. 20A is telling us is asking us what is the mass in grams of each of the following. So we need mass on top, and that is in grams. So let's look at 20A. 20A is looking at the element bismuth. So grams of bismuth. That's what I want my answer in. Well, what do I know about grams of bismuth? Well, if I look at my periodic table, I know that there is 208.98 grams of bismuth in 1 mole of bismuth. Okay? I want grams of bismuth as my answer. I don't want moles in my answer, so what do I need to do with this unit? I need to cancel it out. So I'm going to put 1 mole of bismuth up here. Well, what do I know about 1 mole of bismuth? I know that 1 mole of bismuth has 6.02 times 10 to the 23rd atoms of bismuth. Now I can cancel out those. How do I cancel out these atoms? I look at what they gave me in the problem. They gave me 6.02 times 10 to the 24th. So 6.02 times 10 to the 24th atoms of bismuth. And look, I can cancel out that unit, and I'm left with grams. So I'm going to go ahead and multiply across the top 208.98 times 6.02, and I'm going to get 1258.06 times 10 to the 24th. And then I'm going to put that over 6.02 times 10 to the 23rd. Okay, so if I divide that out, 1258.06 divided by 6.02, that's going to be equal to, same thing we had, 208.98 times 10. Now remember, when you're dividing exponents, with scientific notation, when you're dividing with scientific notation, you subtract the exponents. So 24 minus 23, so times 10 to the first. Can I leave it like this though? No, I can't, because I don't have 1 digit before the decimal. I have 3. I only want 1. So 2.0898 times 10 to the, that is now 2 more further away from where it's supposed to be, so that's going to be times 10 to the 3rd grams of bismuth. Okay, so I did this video during my planning period, so there was no one to ask me questions or give me any confused looks when you didn't get anything or when I said something crazy. So if you have questions, you need to ask. Send me a message. Also, this is a YouTube video, so you can stop, you can pause, you can rewind, you can watch it over. You can also look for other YouTube videos to explain it, okay? If I can't explain it like you understand it, search. Y'all Google things all the time and search for things on YouTube all the time. Look for other ways to understand. I will be back the next class session for those that are face-to-face. For those of you that are virtual, please send me a message if you don't get something. I'm going to post a discussion question for you to post your answers in like I've been doing with your work previously. But if you have questions, please don't hesitate to ask.